So we've done a number of examples that have included the force of kinetic friction. So kinetic friction being the friction an object experiences as it is sliding on a surface. I want to take a few minutes to talk about static friction as well. Keep in mind, static friction means the object is not sliding on the surface. It doesn't necessarily mean the object's stationary, at rest, though that certainly could be the case. The all-inclusive, all-encompassing definition is that the object's not sliding. When we say that the force of static friction is the coefficient of static friction times the normal force, this is actually the maximum possible value. It's not necessarily the actual value of the friction force. For objects in general, the coefficient of static friction is typically approximately 75% of the The kinetic friction is approximately 75% of the static friction. That coefficient of static friction is always larger than the coefficient of kinetic friction, which, if you've ever moved a heavy object like a fridge, a big old couch, just a heavy box, when you start pushing on it, it is always harder to get it moving than to keep the object moving once you have it sliding on the ground. And this explains why. The coefficient of static friction is what is holding and determining the maximum possible value of static friction, which is keeping the object in place. So for example, let's say we have our fridge. The fridge is sitting on the floor in our kitchen. We are going to slide it, for whatever reason, to the side. There is a specific coefficient of static friction between the feet of the fridge and the floor. And then the normal force would depend upon the weight of the fridge. Because the normal force straight up, mg straight down, there is not any other vertical forces. So let's say, I'm just going to make up a number. Coefficient of static friction is going to be pretty high between the feet and the floor. I'm just going to make up 0.9. I don't know what it actually is. It depends upon the numbers, but it's fairly high because it doesn't slide super easily. The normal force, let's say the mass of our fridge, honestly, I have no idea what that would be, so I'm making up that number as well. So if these were the values for our fridge, if I was to calculate the force of static friction, I would have 0.9 times 250 times 9.8. So 2205 newtons. I'm not worrying about sig figs at the moment. I'm just making up numbers. I want to just talk about what this means. This is the biggest the force of static friction can be. So suppose we come to our fridge. As I've already mentioned, we know the normal force and the force of gravity are balancing each other out because there's no other vertical force. If we walked up to the fridge and pushed on the fridge with a force of 100 newtons, well, that push is not hard enough to make the fridge move. So if we push with 100 newtons, the fridge won't move. To get the fridge to move, we have to push with a force just greater than this 2,205 newtons. That 2,205 newtons is the biggest the static friction force will be. So if I push with a force less than that, the fridge won't move. But there has to be a static friction force, because if there isn't, and the only horizontal force we have on the fridge is 100 newtons, then there would have to be an acceleration, according to Newton's laws, right? There is an acceleration if there is a net force acting on the object. In that horizontal direction, if that 100 newtons is all there is, then there has to be an acceleration in the x direction. But we're not pushing hard enough to make the fridge move. So what that means is there is a static friction force between the feet of the fridge and the floor, and it is 100 newtons. The static friction force will be 100 newtons in this case. That is not mu times n. We've already calculated mu times n. This is the force needed, though, to keep the fridge from moving. If we came and pushed on the fridge with a force of 1,000 newtons, that's still not reaching the maximum static friction force. If we push with 1,000 newtons, the fridge still doesn't move. And again, that's because we are not exceeding that maximum static friction force. But if the fridge is not moving, there's no acceleration in the x direction, then the friction force must be counteracting our push. The force of static friction would be 1,000 newtons in this case. So the force of static friction varies depending upon the other forces acting on the object. The force of static friction will vary up to this maximum value. If we push with 2,000 newtons, we're still not at this maximum static friction force. The fridge still won't move. But I know the static friction force will have to equal the force of friction to keep the fridge in place. So we essentially can apply any horizontal force up until this 2205 newtons, and the fridge won't move. The static friction force will equal whatever our pushing force is. So to get the fridge to move, we have to push with a force greater than the mu s times n, in this case the 2205 newtons. Once we get the fridge moving, the friction force becomes kinetic friction because the fridge will be sliding on the floor. Because the coefficient of kinetic friction is smaller than the coefficient of static friction, it's easier. That kinetic friction force that is opposing the motion is smaller than the 2205 newtons. And so to keep pushing it, it's not as hard to keep it moving because you're now just counteracting that kinetic friction as opposed to trying to exceed the static friction. So problems with static friction are a little more involved, in that we have to reason through if the object's going to move or not. We have to compare the friction force needed to make it move compared to the friction force needed to make it do whatever it's doing in the problem, which I'll go through a couple examples so that makes more sense. So for example, pause the video, read through this question and determine what you think the answer is, and then watch the solution. So this box having a weight of 100 newtons, that means the pull of gravity is 100 newtons. It's sitting on a surface, so there's a normal force. The pull is only horizontally. We know the normal force has to equal mg, or 100 newtons in this case, simply because the only vertical forces are the normal force and the force of gravity. So they have to balance each other out in order for there not to be an acceleration in the y direction. So we know the pull in this case is 30 newtons, and we want to know if the box moves. So we always need to compare to this maximum possible value. So whenever we say the force of static friction is the coefficient of static friction times the normal force, this value gives us the biggest that normal force can be. The static friction force can be. So in this case, they've given us a static coefficient of 0.4. We know the normal force is 100 newtons. So the maximum force of static friction is 40 newtons. What this means is we would need to pull with a force greater than 40 newtons to get the box to move. The problem is telling us the box is being pulled at 30 newtons. Since that's less than 40 newtons, no, this box is not going to move. Now, another question you will sometimes see with problems like this is, okay, we now know the box is not going to move. What is the force of static friction in this case? So we know the box is being pulled to the right with a force of 30 newtons, but we know it's not going to move. That means there has to be a force of static friction to the left, keeping it from moving. But it can't be 40 newtons to the left, because that would give us a net force to the left, which would mean it's moving. The force of static friction has to equal that 30 newtons in this case to keep the box from moving. So static friction's a little different. We have to consider what the object would do if there was no friction. So here we know the static friction has to pull to the left or act to the left to oppose the pull to the right. And since we know we're not pulling harder than this maximum possible value, we know the object's not moving, it's not sliding on the floor. So that static friction needs to equal the 30 newtons. I'm going to do a couple more example problems in separate videos just to give a little more practice. So go through those and make sure you understand how to approach problems with static friction.